Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 29. So this is the start of chapter 5. We're going to be talking about polygon sums today. And I want to know, is there a formula for the sum of the interior angles of any number of sided polygon? Remember, we've studied triangles and we know that all of the interior angles of a triangle add up to 180, no matter the triangle shape. Is there a formula for other polygons? So let's investigate. Is there a polygon sum formula? Get out a pencil, paper, and protractor. Draw 3 different size polygons with 4 sides each. So we're drawing quadrilaterals to start with. Carefully measure the interior angles and add them together to find the sum. Compare the different quadrilaterals you drew. Was the sum comparable? Is there an average? Can you guess what might be the sum for each of these? Now repeat the investigation with pentagons. So draw 3 different size pentagons, that's 5 sides each. Measure all the interior angles and add them to find the sum. See if your pentagons are comparable, even if they're all different shapes and sizes. So here's what I did. I drew 4 dots so that I could draw a quadrilateral. And then I measured the interior angles. When I added them together, I got 361. I drew a different quadrilateral and I got 360. My average was 360.5. I'm not sure that it should be a decimal, so I'm going to go with about 360 for quadrilaterals. Now I'm drawing a pentagon. And I've already measured all of my interior angles. The sum is 537. I'm going to draw another one and I get 540 for my sum. That average is 538.4, but maybe it's about 540. That's a pretty even number. So can we make some conjectures? What did you get for your quadrilaterals? I think the quadrilateral sum conjecture is the sum of the measures of the 4 angles of any quadrilateral is going to be 360. What about a pentagon? My pentagons were about 540. That's an even number that came out of that. So the sum of the measure of the 5 angles of any pentagon is 540 degrees. Now I'm going to look at this chart. So the number of sides of the polygon, we know that 3 sides is a triangle, and that the sum of the measures of the interior angles for a triangle is 180. When we did our quadrilateral, we got 360. And our pentagon, 540. Can you see maybe how these are adding every time? And what are we adding by? Looks like 180. So if I added 180 to 540, I would get 720. If I added 180 to 720, I would get 900. Now, how can we come up with a formula? Let's look at a quadrilateral here. What if I broke it up into 2 triangles? Can I draw any more triangles without undoing what I've already done or overlapping? No, I don't need to. So I have interior angles here. Here is now 2 parts. And this one is now 2 parts. But even though this is 2 parts, when I draw this diagonal in it, I can still see that these would all be the interior angles summed together. And these 3 make a triangle, and we know that a triangle is 180. And these three make a triangle, and we know that a triangle is 180. So if I added the 180 from this triangle to the 180 from this triangle, I should get everything inside the quadrilateral. So 180 times 2 is 360. What about in a pentagon? Now this is an oddly shaped pentagon, but let's see, how many triangles can I draw in it? I can draw one here, and then I have a quadrilateral, so I know I can draw another set of triangles. So overall, I have 1, 2, 3 triangles. All of my triangles are going to be included in my interior angles, even though it maybe breaks this angle up into two different ones, but I would still be able to add them together. So 180 plus 180 plus 180 is 540. So now we're starting to see that we can get how many triangles in each of these polygons. I can get the number of sides minus 2. That's how many triangles I can get into each polygon. And then if I multiply the number of triangles by 180 degrees, then I will get all of the interior angles. So my polygon sum conjecture is the sum of the measures of the interior angles of an n-gon, so any number of sides. What did I say that was? It's 180 degrees times the number of triangles, and the number of triangles was the number of sides of anything minus 2. So in a triangle, we have 3 sides. 3 minus 2 is 1. 1 times 180 is what the sums of the interior measures of a triangle. Another way that you could write this formula is just to distribute this 180. And so you would have 180 times n minus the 360, which is 180 times 2. So two different ways to write this formula, and that would give you the sum of the interior angles of any sided polygon.